Okay, in this video I'm going to talk about the Pythagorean theorem. So the theorem says that in any right triangle, if we denote the sides by A, B, and C, so the theorem says that A squared plus B squared is equal to C squared. So this is the Pythagorean theorem, and so let's prove this. So there are multiple proofs of this theorem, so I'm going to show the proof that involves the area. So we have this triangle, so A, B, C. So what we do is we extend these two sides, and we measure the segment of the length A here and of the length B here. So this segment has length B, and this segment has length A. So then we construct. So then we draw the line after the with the right angle here and with the right angle here, and we can draw here the segment of the length B here and connect this and draw here so draw here the segment of length A here and connect like this. So now notice that what remains. So notice that this figure, this large figure, is a square. Yeah. So first it's a rectangle because it has three right angles, right? So this angle should be a right angle as well. So all four angles are right angles. So therefore it's a rectangle. But also these two sides are equal to each other. So let's highlight this. This side is equal to this side. Those that I highlighted with blue. So both of them are equal to A plus B. So therefore it's not just a rectangle, but it's a square. So now then the other two sides should be also A plus B. So this side is A plus B and this side is A plus B. Therefore the remaining segments, so this segment can be calculated as B. So it's A plus B minus A, right? So it must be equal to B, and this segment must be equal to A. So it's A plus B minus B. Okay, so and we connect here. So notice that we have these four right triangles. So let's highlight them in green. So this triangle, this triangle, this triangle, and this triangle. So these four right triangles, so they all have so they're all four right triangles. One of the angles is a right angle, and they all have the same sides. So A and B, right? The sides of the sides of the right angle. So therefore all four of them are equal to each other, right? So now, so this means that this side is also C everywhere. So these four segments must be equal to C, all of them. So now let's consider the area. So let's find the area of the original triangle with sides A, B, and C. Right. So a right triangle. So like we constructed this additional triangle equal to it, right? And what we have here is basically a right angle, rectangle. It's a rectangle with the sides A and B. So the area of this whole rectangle is equal to AB, right? We know that now this rectangle consists of two equal triangles. So the area of each of these triangles should be then 1/2 of the area of the rectangle. So AB over 2, this is the area of each rectangle. So like of each of these green rectangles in particular. So it's AB over 2. So this, and this. So these four triangles, they have area AB over 2, right? So now if we calculate the area of the whole, this large square, so we calculate it in two different ways. So first it's just the side of this large square squared. So A plus B squared. This is the area of this large square. On the other hand, it's equal to the sum of the areas of the parts that we see on the picture. So this, yeah, so we haven't established yet that this is a square. So like this quadrilateral in the middle with four sides C and these four triangles, right? So the four triangles, their area is AB over 2, so their combined area would be 4 multiplied by AB over 2 plus the area of this quadrilateral in the center. So now about this quadrilateral. So notice that if we notice the angles, so like let's say this angle is alpha, then this angle would be 90 degrees minus alpha, and this angle would be equal to it. So this is also alpha, and this is 90 minus alpha. So then this angle is calculated as 180, so the full angle, minus alpha, and minus 90 degrees minus alpha. So this angle is equal to 180 minus alpha minus 90 degrees minus alpha. So this is equal to simply 90 degrees, because alpha and alpha, minus alpha and plus alpha cancel each other, and we have 180 minus 90. So it's in total 90 degrees. So this is also a right angle. So this is a right angle, and similarly, like all four of them are right angles. So therefore, this figure in the middle is a square. Is a square with the side C, right? So the area of this square would be C squared. So what we wrote here is the area of this large square with the side A plus B, calculated in two different ways. On the one hand, it's A plus B, so the side of the square squared. On the other hand, it's the sum of the areas of the parts that it consists of. So four equal triangles with the area AB over 2 each. So 4 multiplied by AB over 2 plus the area of the central square, which is c squared. Okay, so now we simplify this. So on the left hand side we have a squared plus 2ab plus b squared. On the right hand side we have 2ab plus c squared, right? So now 2ab and 2ab cancel each other, and what we have is a squared plus b squared is equal to c squared, which is exactly what we needed, what the Pythagorean theorem states. Yeah, so that's what we needed to prove. So yeah, so this concludes the proof.